Okay, good everyone. Good everyone. Welcome to kossydgreat YouTube channel. Today we are going to talk about the dimension of what? Physical quantities. We are going to talk about the dimension of what? Physical quantities. Now, we are going to find the derived unit or dimension of what? The following quantities. 1. Pressure. 2. Work. 3. Impulse. 4. Potential difference. And 5. We have surface tension. Now we still have more order of what derived unit we are going to talk about. Now what we are going to do is what? Let us take what? Solution. Now when we start, number one says pressure. The formula for pressure is what? Force over what? Area. Now remember that force is mass times what? Acceleration over what? Area. So pressure is equal to mass. If you look at the unit of mass is measured in kg. So we have mass as what? Kg times. Our acceleration we have discussed before is meter per second square all over. The area is meter square. Now let us solve this mathematics. This is what? Kg times, we have meter per second square divided by what we have here, which is what? Meter square. So therefore, this is kg times, we have what? Meter over second square. This we have over 1. When we change this into multiplication, we are going to have 1 over what? M square. So this m can cancel this m, leaving us 1m. So what can we say? That pressure is given as what? Kg over, this time this will give me what? ms square. Which implies that what? We have what? Kg per, this is what? Meter per, this is what? Second square. We are putting 2 per because both of them are what? Denominator. Or we can have kg meter minus 1, because of the denominator we have s minus what? 2. It is what? Denominator. So this is what? The derived unit of what? Okay, now since we have proved that pressure is this, the derived unit of pressure is what? This. We are going to find the dimension of what? Pressure. Now under the dimension of what? Pressure, which is given as what? Kg meter minus 1, s minus what? 2. when we talk about dimension, we are trying to represent the fundamental quantities with their symbol, where mass is represented with capital M, length is equal to L, then time is represented with what? T. So representing these physical fundamental quantities with their symbol is what we call dimension. So the dimension is equal to M, L minus 1 and T minus 2. So this is the dimension of what? Pressure. Well, this is the derived unit of what? Pressure. So we have number 2. Number 2 is what? Work. What is work? Work is equal to force times what? Distance. Remember, force is equal to what? Mass times acceleration multiplied by what? The distance. So this is equal to the mass is represented with G, kg, times the acceleration is what? M meter per second square, times the distance, which is equal to length, is what? Meter. So this is equal to kg times what? Meter over second square times what? This meter. So in this case, we are going to have kg, meter times meter is what? Meter square over, we have what? Second square. So I can say that work is equal to kg meter square per what? Second square. Or we can have kg meter square, we have seconds, remember per, this is denominator, we have what? Minus what? 2. This is the derived unit of what? Work. For dimension, now you can see this is the what? Derived unit of what? Mass. But the symbol of mass is M. The derived unit of what? Length. But the symbol of what? Length is what? This. And this is seconds. The symbol of time is what? T minus what? 2. So this is the dimension of what? Of work. Okay, number 3. In number 3 we have impulse. The impulse has a formula of what? Force times what? Time. Now, for impulse, we have force as what? Mass times acceleration multiplied by the time is what? Seconds. So in this case, we are going to have kg times meter per second square is acceleration times the time is what? Seconds. So we are going to have kg meter over second square times what do we have here? We have seconds. Now in this case, we can have this 1 over 1. This can cancel, we have s. This can cancel, we have 1. So this we have kg meter. Kg meter times 1 is kg meter over, we have what? Seconds. So the derived unit of this is what? Kg meter per seconds. But for dimension, we have the kg is represented as mass, capital M. Meter is the length, which is represented as what? L. Per. The time is seconds, we have time. Or we can have M, L, T minus 1. So this is the dimension of what? The impulse. But this is the derived unit of what? Impulse. So we have another one. We have another one, which is what? Potential difference. Potential difference. We use V to represent it. Now, what is potential difference? The formula is what? Work done over what? Charge. So potential difference is equal to work done over what? Charge. Now, in this case, remember that work means force times what? Distance. Over, we have charge. Now, where force is equal to what? Mass times what? Acceleration. And the charge is equal to what? IT. Current times time. So potential difference is equal to mass times what? Acceleration as force times what? Distance over what? We have what? IT. Remember, this is a derived unit. We are trying to express everything to what? Fundamental. So therefore, we are changing this particular thing to fundamental. Current is one of the fundamental. Time is what? Fundamental. Mass is fundamental. Distance is fundamental. But acceleration is not fundamental. So we need to convert this acceleration to what? Fundamental. So to convert it now, potential difference is equal to what? Kg times the acceleration is what? Meter per second square times the distance here is what? Meter all over. We are going to have current times what? The time is what? Seconds. So potential difference is equal to, I can have the potential difference is equal to this time, this will give me what? Kg meter per second square. Kg meter per second square times meter all divided by current times what? Seconds. So potential difference is equal to, we have Kg meter times meter is what? Meter square over second square all divided by is. So this one over 1. We are going to have Kg meter square over second square times, when this thing changes to multiplication, we are going to have 1 over what? Is. Current over what? Is. So potential difference is equal to this time this will give us Kg meter square over this time this will give us what? Is3. So therefore, the derived unit of this is what? Kg meter square. We have current minus 1. Then we have S minus what? 3. So this is what? The derived unit of this. But for dimension of this, we are going to have mass as kg, length as meter, I minus 1, and the time minus 3. So this is what the dimension of what? Potential difference. Remember, as we said, thank you for watching us. God bless you.
I was just joking.